How do we imagine such a rock would form? Well, the history of the study of these rocks really goes back, well, it goes back 70 or 80 years, but the key early work was done by a man called Alec Trendall, then with the Geological Survey of Western Australia, and he mapped out these rocks in enormous detail. And later, because of the iron ore mining and the iron ore exploration, lots of drill holes were drilled through the rocks so that people could get an even closer look at what they were like inside. And it was discovered in doing that the finest layers in these rocks are only about 1 millimetre thick, and that even those millimetre thick layers could be traced for tens or even hundreds of kilometres. So now we have a very strange geological situation. Somehow, we not only have to explain why all the iron is here, we have to explain how layers so thin could be so extensive. That's an extremely rare thing in geology. Consequently, there's been a lot of work done on these rocks over the last 50 years or so, trying to understand those things. One of the first things that comes out is that if you look at the distribution of these sorts of rocks through time, the biggest ones, the biggest, thickest sets of layers of these all occur around, well, at least older than 1.8 billion years ago and younger than about 2.7 billion years ago. There are some older and there are some younger ones, but there's a big concentration in that time interval. So now we have very peculiar rocks at a particular time interval. And those two things are an important part of the story that's gradually being revealed by research on these things.